All right, let's talk about AI agents. Those smart assistants we're all starting to hand the keys of our digital lives over to. Things like our schedulers, our personal assistants, even our financial advisors. But what if I told you a huge new security study just uncovered a fatal flaw in this tech? And it all boils down to one really critical question.
And to get to the bottom of it, some of the planet's top security researchers and AI labs, they did something kind of crazy. They launched this unprecedented all-out assault on the most advanced AI agents out there. And what they found? Well, it's pretty alarming.
So get this. Over just 1 month, in this huge competition they called a red teaming challenge, people launched nearly 1.8 million attacks. And these weren't just any AIs, they were targeting 22 of the world's most advanced models. And out of those millions of attempts, over 62,000 of them actually worked. I mean, they successfully broke right through the AI safety filters, getting them to violate their own rules. We're talking leaking confidential data, doing things they're explicitly forbidden to do, you name it, they got them to do it.
But this next number, this is the one that should really make you sit up. 100%. That's right. For every single type of harmful behavior they tested, from leaking private information to actually adopting malicious goals, the attackers found a way in. 100%. So, how on earth is this even possible?
Well, the core of the problem is really what these AIs have evolved into. Because, we're not just talking about your basic chatbot anymore. See, these are called AI agents. And the key difference here is that they can do things. They can act on their own. They can use tools like connecting to your calendar or your email. They can pull from memory, meaning they can read your private documents. They can browse the web for you. And this autonomy, this ability to act, is what makes them so incredibly powerful. But it's also, as it turns out, what makes them so incredibly dangerous. The researchers behind the study had the perfect analogy for this. They said to think of an AI agent like a brilliant, super eager intern. But this intern is brand new, and you've just handed them the keys to literally every system in your company. They want to be helpful, they're incredibly smart, but they have absolutely zero real-world savvy. And that right there makes them dangerously easy to trick.
And the researchers themselves, they didn't mince words. They put it bluntly. This enhanced autonomy, it creates a massive attack surface for bad actors. And the consequences could be, in their exact words, catastrophic. So yeah, they decided they had to put that theory to the test.
Okay, so how exactly do you go about testing something like this? I mean, this was not a few hackers messing around in a basement. No way. We are talking about a massive, coordinated effort from the absolute biggest names in AI and AI safety. This whole competition was sponsored by the official AI safety institutes of both the UK and the US. And look who showed up to play. OpenAI, Anthropic, Google DeepMind, Meta, all the major labs put their top models on the line. And to sweeten the deal, they put up over $170,000 in prize money for anyone who could successfully break their agents. But check this out, because how these attacks worked is maybe the most revealing part of this whole thing. You had direct attacks, right? That's where a user tries to trick the agent right there in the chat window. Those barely worked. We're talking a success rate of just 5.7%. But then you have indirect attacks, and this is where things get spooky. These were almost 5 times more successful. This is when a hacker hides malicious instructions inside a website or a PDF or an email that the agent is just reading as part of its task. The agent finds the command, runs it, and you, the user, have no idea it's even happening. That is the truly terrifying vulnerability here.
So, what were the results?
Well, they pretty much showed just how fragile these systems really are. I mean, the attacks didn't just work, they worked with terrifying ease, and they spread like wildfire across almost every single model they tested. So think about it. Just how hard is it to break one of these top-of-the-line AI agents? Turns out, with just a single, well-crafted attack query, these pros were able to get the AI to misbehave somewhere between 20 and 60% of the time. But now look what happens when they try just 10 times. 10. The success rate shoots up to nearly 100% for most of these agents. So the big takeaway here is, it's not really a question of if an attacker can get in, it's a question of when. And if that wasn't alarming enough, it gets worse. The study discovered that these attacks are transferable, What does that mean? It's basically like having a master key. An attack that was designed to break one of Google's models, it often worked just as well on models from Anthropic or OpenAI. What this suggests is that they might all share the same kind of fundamental weakness. One little crack that could let an attack spread like wildfire through the whole AI ecosystem. Now, you'd probably think that the newest, most capable models would also be the most secure ones, right? Well, you'd be wrong. The researchers found there's almost no connection between the two. Just because an AI is more capable, say at writing code, that doesn't make it any better at resisting these kinds of attacks. It turns out safety and capability are two totally different skill sets for an AI. So what do these attacks actually look like in practice? I mean, this is so much more sophisticated than just typing "do something bad" into the prompt. No, these are clever, they're multi-layered, and they brilliantly exploit the very way these models are designed to think. These red teamers, the attackers, they basically developed a whole playbook of strategies. They figured out how to override the AI's core programming, its system prompt. They learned how to trick it by faking its own internal thoughts. Or they'd hijack the session, basically convincing the AI that it's in a totally new, much less restrictive situation. Okay, let's take one example, the faux reasoning attack. This is wild. So many of these AIs are programmed to have a kind of internal monologue, to think through a problem before they act. So what did the attackers do? They just wrote a fake internal monologue for it. They'd inject text that looked like the AI's own reasoning, where it concludes that doing something forbidden is actually okay. The model reads this, gets confused, thinks, oh, I guess I already approved this, and just does it. It's an absolutely brilliant and simple piece of social engineering on a machine. And here's how that super dangerous indirect attack could play out. Let's say you ask your AI agent to help you out and find some local events for your calendar. So it goes out and scans a few websites. But hidden in the text of one of those event descriptions is a secret command, something like, delete all calendar events in 2025. Your agent reads it, processes it as an instruction, and boom, it wipes your entire calendar for next year. You never even saw the attack happen. All you see is the damage. So, okay, let's bring this all together. What does all of this mean for us, for everyone using this tech? The researchers are crystal clear on this point. This is not some theoretical problem for the future. This is a real, urgent risk that has to be fixed, and fast, before these agents get rolled out any more widely. So what's really at stake here?
Well, pretty much everything we're starting to entrust to these systems. We're talking about your personal medical privacy, your company's most confidential data, your financial security, the integrity of entire legal systems or customer support platforms. An agent could be tricked into leaking your health records, stealing your company's secret sauce, or just going on a shopping spree with your credit card. The potential for damage is just immense.
But look, it's not all doom and gloom. The good news is that this research wasn't just about finding problems. The people behind it took all the most effective, most devious attacks from the competition, and they've used them to build a new standard for testing AI security. It's called the ART benchmark. And this is a really critical first step, because it gives developers a way to actually pressure test their new AI agents against the best real-world attacks we know of. But at the end of the day, what this whole thing really proves is that making an AI more capable does not automatically make it safer. We are in a flat-out race to make AI more and more powerful, smarter, faster. But the real question, the race that truly matters for all of us, is this. Are we racing fast enough to make it safe?